is going to, there we go. Thank you for the reminder, much appreciated. Okay, let's see. Tidyverse was loaded. Let's see why. Forgive me what I'm doing here. Don't worry too much about what I'm doing.
Angelique?
Yeah, go ahead.
Well, we can't see your screen at the moment.
What's going on? Apologies. I wonder what happened there. Okay. Forgive me, I just want to make sure I'm actually helping you guys into the right direction. Okay, your library should be loaded at the moment. Don't save, there we go, righto. And that is now the part that we needed to essentially get to today. How to load the packages. Now, maybe I can just sit still with the packages for 1 second and you can actually, why do I have to load these packages? Why is and what we are seeing is our studio, right? And this square you're seeing where it says R 4.3.2, that's actually R. Our studio is a graphical user interface. So it's easier to use R. And there's a little bit of a point and click going on here. And it makes it a bit nicer because you can see file, edit, code, view, and the menu at the top. And you can see the files here at the square down. We'll look at why it looks like it looks for different reasons. But R has so many applications. You can write an R package like the ones we downloaded and the code I sent you. It was Tidyverse, Hexbin, Patchwork, and our SQLite. And we're going to be downloading and activating and all these things in a bit, right? Well, talking more about them. But every single package has a different purpose. And we know all of us in the room here come from very vast and diverse disciplines. I come from behavioral sciences. I know Anne and Amy comes from much different sciences than I do. And every package has a different purpose, and you might find one better than the others. But we are going to use these 4 sets of packages that we have installed and now activated on our PCs. Now, very important that at times we're going to have to reload our library. What we did now, the library hex bin you're seeing on my screen at the moment, you might have installed the package, but it doesn't mean it's been activated, right? How do we activate it? We pull it out of our library. So we use library and then curly brackets, the package name. No inverted commas in the middle, nothing like that. R will very clearly tell you when something is wrong. Okay, dokes. Let's continue. Boom, boom, boom. How do you now update these packages? And also, you might not know this, but R already has packages pre-installed to do the basic things that we are seeing here at the moment. So you might want to do this while we're chatting now, because it might take different times for various people. We're going to go to Tools. So I want you to go with me. Click on Tool in the menu bar at the top. It's the second last icon. You must say check for package updates. So we're going to click on that. We're seeing 2 packages that for me, yours might differ because I use R maybe a little bit more than you. So it might be that you have far more packages to update. So if you want to do that, please go ahead and say install updates, and you can see there's a bunch of things happening now. On my end, yours might look different, and it installed. So quickly start with that while I continue the introduction of the next session. I'm going to stop here. Everyone is updating their packages at the moment. Is this correct? If this is not, please type in the chat, I need help or something of the sort. Okay, thank you for the thumbs up, Peter. Much appreciated. Thank you, Yastil. Much appreciated. Pamela, thank you. Help me with your pronunciation. Is it Walia? How do you pronounce your name?
Walia.
Walia. Am I saying it
Walia.
right? Walia. Okay, thank you.
Yes, that's
you can
correct.
correct me
Yeah.
as many times. I want to learn a lot. Okay. Thank you so much. Okay.
Sure.
So it seems like everyone's on the right path. Let's quickly, so there is a way to manually download the data and you can add it into a folder, but I don't want to do that with you now. I want to show you the cheats, the way to make your life easier when using RStudio. My motto in life is work smart, not hard. And I truly hope that I can give a little bit of wisdom to you while learning R. So we are going to quickly jump in and say what is R and what is RStudio. And I already kind of alluded to this, but let's just recap that. So the term R is used to refer to both the programming language and the software that interprets the scripts we're going to be working with today, right? RStudio is a very popular way to write R scripts and interact with the R software. So to function correctly, RStudio needs R, and therefore both needs to be installed in your computer. So I showed you now, you can see my screen. Currently, the half of the screen you're seeing, that is R, but R is embedded in RStudio. So you might ask me, Angelique, now why do I need to use R? And you might have your own specific reasons for attending this particular workshop, but I'm going to tell you nonetheless why I think you need to learn R. So R does not involve lots of point and clicking, and that's a good thing. But there's a little bit, RStudio has point and click. You can see that on the screen, right? But it's not like SPSS or anything. This means you have full control over what you're doing with your data. But we're going to be opening a script very soon. And you can rerun that script as many times on different data sets, etc., as you want. It's for reproducibility of research. And that's a big thing. It's always been a big thing, right? How do we reproduce exactly the same analysis on various data sets? R code is great for reproducibility. I just spoke about that. And just not to blow my own whistle, but R is widely used in academia and industries, such as pharmaceuticals, biotech, which are industries you might be in, right? When we work in these, let's say, labs, they expect the analysis to be reproducible, and R can do exactly that. R is interdisciplinary and extensible. So I mentioned there are many, many packages in R. Maybe I can quickly show you here. If you go in the third little square where it is packages, and you scroll down, okay, one day when I scroll down, boom, boom, where it's ticked, you can see it's the ones like Xpin. We already installed that, right? ggplot. You can see Lubridate, but these are things that I ran on my end, so you might not see them on your end. It's totally fine. If we're going to use them, I'll show you how to get hold of them. You can scroll down, boom, boom, boom. So these are like the ones that came pre-installed on RStudio. But there's 10,000 plus packages that can be installed. And R provides a framework that allows you to combine statistical approaches from many statistical disciplines to best suit the analysis frameworks you need to analyze your data. So example I want to highlight is image analysis, GIS, time series, population genetics. Let's say latent variable modeling. This is what I use in my PhD, but I did not know about R back then. I wish I did. It would have made my life so much easier. So R also works on data of all shapes and sizes. It could be 100 people, it could be millions of data sets. High quality graphics. Oh my, how many times have I argued with publishers to get my graphics published? However, when I learned R, that nightmare is being removed. And R has a large welcoming community. I'm going to copy and paste this for you into the chat. There are online calls, there's South African communities too. Our Ladies Global, there's Our Ladies Botswana, Our Ladies South Africa, and they're not just open for ladies, right? Please, guys, attend these calls. If you want to learn more after what we do this week, and you step away and you said, you know what, yes, I want to do more, join some of these communities. They are amazing. I speak at some of the Our Ladies events quite often in Africa about the carpentries and how we integrate our lessons with R. So this might be a great opportunity for you to grow more your R repertoire. Sorry, what? I needed a sip of water. Let's go on. R is not only is R free, it's also open source and cross-platform. So what is very cool is at the moment, I work for the Carpentries, right? And I like analyzing data, making maps. Actually, maybe I can pull up one of my maps I did. It's, oh, okay. Yeah, it's not on my PC. It's not on this one here because I use my Mac for doing that. But I used R, and I'll get a blog post in a bit when we take a break. I'll show you what I did in R. We hosted a conference online, and we had a bunch of people from over the globe that attended, and I made a map and where everyone came from in R, and I published in the blog post. It looks so cool. Well, I think it's cool, right? I'm sure you will too. As soon as we take a break, I'll show you that. And now we're quickly gonna have a look and know your way around our studio. But first, before we go ahead with that, I want you to go and see kind of what we have. This is called the console. What I'm highlighting now, that's called your console. That's literally R running. But I want you now to make it, we're gonna make 4 quadrants. How are we gonna do that? You see that little green plus sign there. If I hover over it, it says new file. I want you to click on that. And it's gonna say R script, boom. You should be seeing that at the moment. Can I get thumbs up if you can see the 4 quadrants now? Well, they're not very equal, right? Let's just change that. Oh, I'm seeing thumbs up. Thank you, Anne. Thank you, Gastile. Thank you, Walia. Godfrey, thank you so much. Okie dokes. It looks like more or less we are getting there. Thank you, Eddie. Okay, awesomeness. Now, quickly just run through the different parts. You have a source. Your source is for your scripts and documents. The one we opened right now. That's your source. This is where you can save your code. This is your script that you save, and this is what's going to be reproducible. I'm going to show you in a bit how to kind of put everything together in a project, but let's first just run through what each of these 4 quadrants really mean. So we have an environment. And when we're going to create new variables and data frames, meaning mini data sets or tables, right? Depending on which language you are used to. Those of you who are used to SQL might talk about tables, data frames. I use them mini data sets. That's what I call them. I don't think it's official language, but it makes sense to me. So everything we're going to create new is going to be in here. You can see it as, you can say export your data set, you can import your data sets. Mine shows how much memory our studio is using at the moment. We have a global environment for different packages. We're not going to be touching this too much at the moment, so don't worry about that. If you drop down R, you can also integrate Python into this, but we are not going to integrate Python in this current workshop. What you're seeing, the quadrant below that, you have files. So it kind of shows all the files on your system at the moment. Yeah, we have plots, and on day 5, we are going to creating plots. It will show up here. You can export your plot then as an image or PDF. I already showed you here with all the packages that are currently available on the base R program. Help, we're going to be looking at different ways to get help within our studio. I shared in the chat with you the ways that you can join a community, and those communities are great ways to ask for help as well. And now you are seeing the quadrant to your left. is called a console. You'll see everything that we run here in your script. It says Untitled 1 now. I know it doesn't look very fancy, everyone. But everything we run here, you can see, it kind of gives you a play-by-play. Any error we might occur, but also come up in here. Right. You can go and change this around eventually if the more confident you get with RStudio, but I would, for the purpose of this workshop, leave it as is, because then your RStudio looks like mine. And then it's going to be much easier to navigate it around when we are doing the actual exercises. Now, we are going to create a new project and subsequently set up a, how can I say, set up a working directory. Apologies, everyone, right? So we start RStudio. You're going to see a couple of things starting and stopping now, but that's totally fine. Here in the right-hand corner where I'm hovering my mouse now, I don't know, can you see my mouse? I don't know if Zoom is this. Can someone, Pamela, is that a new thumbs up? Can you see my mouse here?
Yeah,
okay,
we can.
Awesomeness, thanks, Anne, much appreciated. Let me just, now everyone wants to call me when I'm teaching. This is Murphy's Law, right? It's totally fine, don't worry. So we are going to click on where it is, you should see project none, right? You're going to click on that. And then you're going to click on new project. You're going to see a couple of things happening, a couple of things popping up, right? Can everyone see this? Yeah, okay, awesomeness, that looks good. Great stuff. What we're going to start with now is you're going to click on new directory, because we don't have existing one. We're not, for the purpose of today, going to work with version control, because then that goes to like GitHub. That's another Carpentry's workshop as well if you want to attend that. But we're going to click on new directory. You can also see, just if you want to just scroll down, we're only going to work with new project now, but do we want to create a new R package? Do we want to create a Shiny application, a Quattro package, a Quattro website, a blog, a book? R has so much functionalities, right? But I'm not going to overwhelm you. We're going to click on new project. Boom. I want you to give your directory a name. Mine says data_carpentries_workshop, but you can name it whatever you want to, right? So go ahead, don't click create project or anything yet. Just go ahead and give yourself a directory name. When you are done, please give me a thumbs up. In the chat will be easier because the thumbs up in the actual thing goes away, and then I might miss that, but thank you so much. Great stuff, you have that. You can go ahead and click on browse, and you can see mine is saved on my desktop, right? In a folder. So if I double click on that, you can see, but that's already mine is set up. So don't worry, you're not going to see this at the moment. But my idea is for you to go look for a location, create a folder that says Data Carpentry Workshop, and save the project in there for now. Okay, so don't create these folders yet, the inside. Okay, once you have created directory name, you have added the location, or also known as working directory. So where is everything going to be saved? Where will we export our data sets? Where will we import our data sets? Where will we export our scripts, etc.? Oh, Eddie, that's totally fine. If you create one that's 100, no worries. Please don't go ahead. Don't worry. I'm just kind of going to run it through with everyone. Okie dokes. So once you are ready, I want you to click on Create Project. I'm not going to do it now because I already have one. I'm going to cancel. I'm going to open my project, which I have already on the desktop, project, Data Carpentry, and there's my project. I'm going to open it. You don't have to do this. Yours should already be open right now. So boom, okay? So you can see I already have my environment setup again, it's back to 3. That's totally fine. Righto. Can I please have thumbs up? I'm going to see if you all are in your project at the moment. Awesomeness. I'm seeing thumbs up. Thank you. Okay, I'm seeing a bunch of thumbs up. It's looking good. So maybe I want to show you, let's say you want to change your working directory. I want to show you how to go and do that. I want you to click on Tools and go all the way down to Global Options. And then you're going to see a pop-up. Yeah? If you want to go and if we have a project, and I do recommend you using a project at all times, and you're going to see the absolute benefit of this in like probably the next 10 minutes. If you want to set a working directory, when you're not in a project, you can go browse and you can do that here, right? If you want to change where your R session is set up, okay, you can't see that now. My machine's default is a 64-bit version of R, etc. You can set that up here. Where do you want R to be installed? I will not go and change this if I was you. What I want you to tick, and you can see mine is tick. It says restore R data into workspace at startup. So click that. Save workspace to order on exit, never. Okay. When you're done with that, you can scroll down and say apply, and you can say okay. Okie doke. So the next bit we're going to be doing, we're now going to set up our files within our project. You're going to see I have a couple already stored here. You should only technically see your project in it. Yeah, go ahead.
Yeah, so different projects can have different working directories, correct?
Say that again.
Different projects can have different working directories.
Yeah. Wherever. You might want to save everything on the cloud, but one thing might have, you know, if you have an SSD lately, right? It runs quite quick, the data, if it's saved on the SSD. But if you want to store data on the cloud and you want to access it, etc., you can save it on the cloud, however you want. You don't have to put it on your desktop. It's Angelique that puts it there for the purpose of today. Okay, I hope I answered your question. Righto. So now we're going to create your folder structure. Ooh, Angelique, no, go back. Okay. So you should be seeing that little, let's say that 3D square with R in with whatever you named your project. So now what I want you to do is you're going to click on new folder, and you are going to create 3 new folders. One with small letter data, small letter data -raw, and small letter fig. So that's your next activity. You're not going to see the script at the moment because we're going to set that up right now after this. So you should only have maybe the history as well, maybe not because you haven't run anything in your project yet. So the 3 folders I want you to create right now. So I want you to create the data raw, and the fig folders for me. When you are done, please type done in the chat. I'm going to give you, let's say, 2 or 3 minutes to do that. Awesomeness, Pamela. Thank you so much. Thank you. Thank you, everyone. Thank you. Thank you, Eddie. I actually want to show you something now. Now, when you created your folders there, and oh, I'm on my wrong screen, everyone, but let me just get I'm going to get the project folder open, right? Apologies, there we go. So this is my project folder where my project for R is stored. You should see the same. But double click on this. All these files are now also created in where you put your project. So that's quite interesting. So if I already have data and stuff stored in there, so I'm not going to open it and confuse you further. But I can see my script, I see my project, the fig, data raw, and data file. So that's quite cool. You can see it on that end. So you don't have to open R to actually see what's going on in the folder structure. Awesomeness. Okay, we are done. So now we technically have everything almost set up to start with this bit. So I want us to click on that new file again, click on our script, and then you see it as untitled one. I want you to give it a title. It's going to pop up now, and you give it whatever title you want. And then you are going to see it in the bottom right quadrant. Mine is called R script. So I'm going to open that quickly and we'll close it. So technically, when you create your script file and it's open, our screen should look very similar at the moment. Yeah. Okay. I'm assuming everyone created their script files. Okay, thank you. So I'm going to open a new, how to rename it. I'm going to say file script, and now it just says untitled, and it's not saved anywhere. So we need to save it. So that little save button, save current document, or you can use a shortcut Control S. So you click on that, you give it a name, any name, script. It's a data Carpentry script. And you hit save, right? Then you're going to see I have 2 here now, but then you can see it saved there. I'm just going to, let's just see, and I'm going to delete that because I don't want to confuse you all with me having 2. There we go. Pamela, is that good? Do you need me to go through it again?
Yeah, I'm good. Thank you.
Awesomeness. Thanks. I really appreciate all these questions. I encourage all the questions, please, because online is great, but I can't see your facial expressions. We can't see each other. I'm not sure if we're all on the same page, and I kind of need to check in the whole time. So now, ladies and gentlemen, we have basically a fully functioning R studio setup here at the moment, and that's awesome. We have working directly, we have our packages installed, we have a file structure going on here, we have a saved script. We're almost ready to go. But now there's one thing that I need to help show you before, or tell you at least, before we go ahead. So RStudio allows you to execute commands directly from the script editor, meaning the script where the top left, by using Control and Enter on Windows. So I'm going to put this in the chat. Ooh, Control plus Enter is for Windows. Command, let me just see what that is again. Command and Return is for Mac. Can I quickly see, usually everyone has Windows. Who has Mac machines with them? Who's using a Mac? Or is there anyone using a Mac in the room?
Yes, I do.
Okay, Pamela, that's great to know. Okay, because there's a reason why I'm using my Windows machine to teach, because usually Eddie as well. Thanks, Eddie. It just will help me know that I need to explain both the Windows way and both the Mac way. But the one big difference is just how we run and execute a piece of script. So Eddie and Pamela, the job is on you to say, Angelique, does this work for Mac as well? Please. Okay, so control, oh, Angelique, you spelled that I can't edit that, but control and enter is for Windows. Command and return is for Mac. Okay, so whenever we run a script, we can do that. Alternatively, you can highlight the line or the piece of code you would like to run and hit the run button there. Run, see, control and enter, because this is a Windows machine, it's already picking up that's control and enter. Okie doke, we are almost going to jump in. Now, Angelique, I need help. I don't know where to get help. Yes, I shared those links with you in the chat saying, let's go to the RStudio community, let's go to R Ladies, but I just want to know how an argument works, for instance, in R. So in the bottom right quadrant, you have files, plots, packages, help, view, and presentation, right? I want us to click on help. And you can see it's taking rounding numbers here, but let's say you want to get help with what does it mean? So I'm clicking on mean, and what came up is arithmetic mean, generic function for the trimmed arithmetic mean. So it gives you some instructions on how R works with means, right? We will unpack this a little bit more in the lesson, but this is where you would look for help. Let's see a mode. The storage mode, yeah, this is not exactly what I was looking for. I want that mode there, not the storage mode. So let's see if there was another mode. Click on that. Okay, still gives that, but this is how we search for terms that we might need a little bit of clarification with. It looks very complex at the moment. Here at the bottom, we're going to unpack this in part of the lesson. Right. R also has automatic code completion, which is amazing. You use tab. You're going to see it popping up already. So when we create a new variable or an object, and I'll explain why we use them in those words interchangeably in this workshop later. But when we create a new variable, you'll see it wants to autocomplete the whole time. And tab is going to help you make that autocomplete. Now, how do we find more functions and packages? I'm going to share this with you in the chat. There's a whole CRAN, we call it in R. It's like a database of different packages and different functions. Please take a look at that if you are, maybe you're running your own analysis and you want to use R for your stuff, but we're not really looking at the packages you particularly want to use. So you can look at that. So when we deal with error messages, they will be underlined in red, pretty much like when we work in Word, when it gets the little red scribble at the bottom. Yep. We will deal with that as well. And I want to share something more if you would like in the chat at the moment. It's all in the lesson material, but for those of you who might, oh, the message is too long, they say. Okay, so let me just break that up. Apologies, everyone. I'll be with us in a second. So here's more information about R. So if you want tonight to have some homework, which I don't think everyone wants, you can go and read this. It's all in the lesson material. There's linked in the workshop website as well, but I'm sharing this for you here now. Okie dokes. There we go. And I just want to highlight some key points for us. R is a programming language, and RStudio is a user interface that assists using R. And there are many benefits to learning R, including writing code, ability to use a variety of data sets, and a broad open source community of practitioners and support, right? Files related to analysis should be organized within a single working directory, as we have already set up, right? Let me just show that for you there. Awesomeness. R uses commands containing functions to tell the computer what to do, and we're going to use a bunch of them today, so don't worry. Documentation for each function is available in RStudio under the help folder, or you can ask someone in a forum. There's a bunch of cheat sheets where I will quickly try and find one of them for you. RStudio cheat sheet. Data camp. Oh, there we go. RStudio has their own cheat sheet, people. It is the awesomeness of awesome. It is done for people who aren't necessarily data scientists, who aren't programmers, and are still learning how to use R. Okie dokes. I will one day get there with this. There we go. You can see that link I'm sharing there. So I've realized that if I use the shortcut for copy and paste for Mac on a Windows, it turns my video on. So this is why my video goes on and off the whole time. Apologies, everyone. Righto. There is your cheat sheets. There is, let's just check the time, key points, introduction to R. Can I ask us to take a 5-minute break, a 6-minute break, and we'll return 50 minutes to the hour, just so that we can start the next section on a new breath. So let's return in 6 minutes. So in South African time, that's 9:50. Go get a cup of coffee, go stretch your legs, get a glass of water, cup of tea, and we'll meet each other back here in a bit, okay? Right, so I'm back at my seat, but it's still 1 minute to go, so I'm going to set myself up so we can start the lesson. I have pasted the blog post. Thank you so much, Peter, for reminding me about that. I'm very proud about the map I created. It does look far more difficult to do than it really is, thanks to our packages and some help from the community. Right. Okay, let's just wait for the clock to hit 10:02. Right, everyone. Can I just get a thumbs up if you are back at your desks or in front of your computer so we can start? I just don't want to leave anyone behind because this is where the fun starts. Thank you so much for your thumbs up. I'm just waiting for a couple of more. There we go, Eddie. Thank you so much. Pamela, thank you. I still think, okay, great stuff. Righto. So we are going to literally get diving into creating objects in R. That's what we're going to do now. And I'm going to show you a cheat. Now, I'm not going to do it every way, but if we take a hash, we're in our script now at the moment, right? Because we will always run everything in a script. We ran the packages in the console, I know. However, I just wanted us to get the packages installed, and I want to show you how not to do that in R. So what we're going to do now is I'm going to make a non-executable, non-runnable sentence in my script. And many program languages can do that, and many other programming packages can do that as well. So I'm going to say creating objects in R. Do you see automatically after I started typing this, that turned red? This means we need to save it. Okay, so if I want to make a comment after something, or make a comment, which are, you can see, if I try and run it now here, Control Enter, I did nothing here at the bottom. This is where things get executed. Here at the console, nothing happened. That's for us to make comments about our analyses, about what we are doing currently, everything. Okay, so you can get output from R simply by typing a math in the console. So let's see. 3 plus 5, and we say Control Enter or Command Return. And at the bottom of R, pushed out 8. Let's do another one. You can do this with me, right? 12 divided by 7. Woo! Angelique, divided by 7. No, 7. 1.714286. Right? You all got that? This is so cool. Well, it's quite a fancy calculator at the moment, but I can promise you R can do far more than do basic multiplications. But we can also assign values to objects. And to create an object, we need to give it a name. And this will be followed by assignment operator and the value we want to give it. So let's just unpack what I said right now. We said, right, we give it a name. We're going to, because we are working with biodata here, we're going to kind of stick with theme. So we're going to call it weight underscore, and this is going to be in kilogram. And we're going to use assignment operator. So in RStudio, Alt and minus. Okay, I'm going to copy this into the chat so that you can reference that as well. And there's a different way of doing this in a Mac. So let's do that. The Mac, you do option and a minus. So you do this together, Alt and minus, or option and minus. And then you'll see like a smaller than and a little hyphen, etc. Right? But now we're going to say we have the name, we have the assignment operator, but what value are we going to assign? We're going to say 55. Yeah? And then I'm going to say Control Enter, and boom, something happened in our environment. Who can tell me what happened in the environment? You can unmute yourselves, put it in the chat, whatever. What happened in your environment when you ran that piece of code? We established a variable. And now we can see the value has been added. The name is weight_kg, and the value of 55 has been assigned to that. Right, so this is absolutely, if you think of like an atom and a proton and an electron, on that level, this is the basis of what we do in R, right? And let's continue. So we just spoke about, we first need a name. And we spoke Monday, about how do we name things, right? Variables. And this applies not just to spreadsheets, but to RStudio as well. We chat about that in a sec. So we use the assignment operator, and how we get assignment operator. You say Alt- for Windows machines, or Option and minus for Macs. So just a couple of tips with regards to how you name a value. You want to make it explicit, but not too long. They cannot start with a number because R will think it is a part of an argument, right? R is case sensitive. So if I want to show you something here. So if I type R with a capital, if I want to type weight again, and I put a capital W, nothing's happening. It's not picking up, even though, you see, it picked up, but must be an update. So it picked up weight, but if I hit enter, it makes it a small letter again. We must remember R is case sensitive. So let me just take that away because you don't need that there. There are some names that you cannot use because our names are fundamental function in R's. For instance, if, else, for. In general, I would not rename statistical terms as well, right? Like mean, data, degrees of freedom, weights. But we're using weight_kg here, so that is fine. It's the best to avoid dots with names, because once we are going to start subsetting data or making data frames, you use a dot to kind of go into that data frame. We recommend to use nouns for object names and verbs for function names. And I would use the same style, kind of, when you code. Either use capital letters or use lowercase. Camel case, I don't know if you use camel case, also known as kebab case in South Africa, Sasati case. No, it's not a Sasati case. That's just a bad attempt to a very bad joke. So meaning, let's quickly give you an example of what a camel case looks like. I'll put it in the chat for you here. Something like that, right? That's what it looks like. Just open the chat here so I don't have to write stuff. So now I spoke earlier that we use the word object and variable interchangeably, right? But what are known as objects in R are known as variables in many other programming languages. And depending on the context, object and variable can be drastically different meanings. And I acknowledge that, right? But for this lesson, we are going to use them interchangeably. So when assigning, and getting back to now assigning values to a variable or an object, R does not print anything really, right? Print, if you think it doesn't return something necessarily. You can force R to print the value by using a parenthesis or by typing the object name. So we have that here, right? We already created that, but we want to print it. So you can do this. So you see what I'm doing? There we go. Assignment operator, 55, then I'm running it again. Boom, do you see? It is printing 55 there now. But another shortcut, we already created the variable, so why do you want to recreate that? That's what we did in the previous step. We can just do this and run it, and it'll print 55 in the console, right? And now that R has weight underscore kilogram in its memory, we can see it here in the environment. We can do some math with it. For instance, we may want to convert this weight into pounds. So weight in pounds is 2.2 times the weight in kilogram. So let's just do some basic math. 2.2, and we can use times. That's a little asterisk, mine's on an 8. And we can say weight, woo, there we go. And if we run that, it says 2.2 times 55 is 121, right? So that's one thing we can do. We can do some basic math with it. We can now go and already we have, we can change an object's value, even though we already have 55. So let's say we want 57.5. So we're going to say wait, and we're going to say assignment operator, that's alt and minus again, and we're going to say 57.5, and we are going to run that. And now we can see in your global environment that has changed, it is updated. Now, if we want to do the same conversion, 2.2 times weight underscore, and we run that again, we see 126.6. But yeah, you know, we're doing math, but I want to create a new variable. We can now just put a name in front of that. So I'm going to do that. Weight underscore LB, assignment operator, and let's run that. Boom. We have now a new variable, and we have stored it in our environment. We can now go and see what will happen when we change weight underscore kg to 100. Do you think, let's quickly ask, do you think anything will happen to the pound variable if I change that to 100? Who wants to try? Anyone?
Again?
Do you, will anything happen if I assign the value 100 to weight underscore kg, né? What will happen to the value of weight underscore LB?
It should change.
Do you think it will change? Okay, let's have a look. Let's
Yeah,
take a
because the
look.
value will update.
Yeah, it might. Let's see. So we're going to do assignment operator 100, and we're going to run it. So the value changed, but not the kg value changed, but not the LB. We're going to have to run this one again. So I'm going to show you another trick. If you want to highlight this, you run it, and there it changed. Because in the global environment, we change that information, right? Okay. Another thing is we are doing work in our script, but it's not saved. So you can click save there or control save or control shift in. You can open that with, you know, control shift in is opening your script, or if you want to save it, control S. Righto. Now, the first activity I have for you, it's in the Etherpad as well, but I'm going to save it. Is there a way to automate save? I will quickly have a look on that, but I can't remember that there was autosave. So let me quickly have a look while you are busy with your exercise. I'll paste it in chat right now. It's on the Etherpad online. Let me go down to the Etherpad. Apologies, everyone. I want you to try and do that activity that I pasted in chat. And I just want to screen you, going all the way down to day 3. Apologies. So what are the values for each of the statements of the following? That is the instruction. So please go ahead in your R and you do that while I see if there's an auto save option for RStudio. Seems like there is. When we're done with the activity, I will show you. I just want to kind of see. Sharing a link in the chat for those of you interested in looking into how to autosave. There's a whole discussion about that, so I'll rather take it offline in a sense. So if you want to read more about that, that's fine. Once you are done with the activity, please will you type done in the chat so that I know we can go on. Right, it seems like many of you have completed this. Let's quickly do it together while I share my screen. I'm not going to type it out fully in the essence of time, so I apologize. So let's create a variable called mass, and we assign the value of 57.5. Great stuff, we got that there. Now we're going to create a new variable called age. We're going to assign the value of 122 to that. Then we are going to create a new mass by saying 57.5, the old mass, times 2. Then we're going to create a new age by assigning or taking age minus 20. And then we are going to do a bit of more advanced mathematics. Not really right, but we're going to do that. So mass index is 0.93137254901968. Right, who got that? I'm seeing most of you got that, right? Awesomeness. Okay, and I'm going to continue to save my script. Righto, let's move on. The next part we're going to do is functions and their arguments. So I'm just going to make a little note for myself. Functions and their arguments. There we go. Great stuff. So functions are canned scripts that automate more complicated set of commands, including operation assignments, etc. So oh, Angelique, you can see there's even a spelling mistake you picked up there. Well done, R. Our packages that we're going to use later has a bunch of more arguments, but we're just looking at the basic stuff today as an introduction. So we're going to work with a function called a square root, right? You've heard of a square root before, so let's quickly see what that looks like. I just want to kind of bring us up here a little bit. So we have a clean screen. So what I'm going to do is we're going to use the variable we created, weight underscore kg, and we're now going to assign the square root of 10 to that. Ooh, so square root is SQRT. Do you see how I picked up? And it says base. You see square root base, meaning we are using base R at the moment, and that's totally fine. This is built in. And now if you enter that, it's going to already open up two curly brackets. And if we look at the suggestion you see on the screen, it says X. So it's looking for a value. And the value we want to put in there is 10. And that's what we're going to run at the moment. So we now have weight underscore kg, which is the square root of 10. And it's now changed to 3.16227766016838, right? We can also use another function called round. So we're going to round down or round up a value. So we're going to use round, and we see it's popping up again. So they say it takes a single numeric argument x, which is a value, and returns a numeric vector containing the smallest integer not less than the corresponding element of x. That sounds all very complicated sometimes, but basically it won't be smaller than the x you put in. So we're going to say round, and we're going to round off pi 3.14159, and it rounded down to 3. Now I know that the function in R by default rounds down to a whole number, in a sense. Sorry, I'm Afrikaans. I'm not sure if I'm using the right English math here, right? But to a single digit, right? But we like, how do we know this, Angelique? I don't know how you knew this. I'm going to show you something now. ARGS means arguments. And what argument do we want to know the back end works like, right? So I want to know the back end of round or square root or whatever, right? But I want to now know what does it work and how does it look like? So we're going to say argument of round. I'm going to run that, and you're going to see here at the bottom, it says, the function says x, which is a value, but the digits are automatically set to a 0. So now I know that for the argument round, it's going to round it to the closest whole number or single digit number. But I don't want that. I want it to 2 digits. So I'm going to do that for you now. I am going to say round. I'm going to show you a little cheat here. I'm going to say 3.14159, and I'm going to say comma, digits 2. You see how it's auto-completing for me all the time? I love this. And now I'm going to run again. Boom. Now I have 2 digits. So this is how you can use the arguments function to find out what happens in the background of R, because I told you earlier, you have far more control over R than a normal point and click. Another way to find out what round means, you can say question mark, round, or what, this is instead of using the args, you can use this one. And do you see now our help page has popped up? And here where I'm highlighting now at the moment, it shows us round, X digits, already 0. If we want to use significance, so you can work through this to fully understand what happens on an R level, to make it work for you. Now there's another cheat. Sorry, I want to sneeze, but I can't really sneeze, I don't know why. So we can use this sheet round. We can say 3.14159, and we can just use a 2. Because R knows after the comma comes the digits. So there we go, 3.14, the same. So that's quite cool, right? Also, R does not discriminate in what order we do this. So we can say round digits equals 2, comma, 3.14159. Still gives us that way around. So it doesn't matter what way around in the curly brackets you put it. Let me just see if there's anything in the chat. I'm not seeing anything. There we go. Now, we are now going to move over. Oh, before we move over, any questions about this? Because we're going to move over to vectors and data types now. Okay, it seems like we're all good. Let's go to vector. So vector is the most common and basic data type in R, and it's pretty much the workhorse of R. A vector is composed by a series of values, which can be either numbers or characters. So it's going to be like 1, 2, 3, 4, 5, or cat, mouse, dog, rat. We can assign a series of values to a vector using the concatenate function. I'll show you that in a little bit. For example, we can create a vector of an animal weight and then assign it to a new object, which is weight grams. Let me just take a sip of water. So what we're going to do is we're going to create a new variable called weight underscore gram. We're going to add the assignment operator again. And now we're going to use the concatenate function. We're going to use C, and we're going to put brackets in it. So we're basically now going to create a new variable that has a string of digits. So 50. Don't get confused with SPSS when we use strings, right? Strings is a character there. So in R, when I say string, it's just a bunch of digits connected to each other. So we're going to say 50, 60. We're going to go 65. And we're going to go 82. And we are going to run this. And now we see something quite interesting happening here in your environment. We're going to look at this, but, let's look at it. So it's a numerical. It has 1 to 4 entries, and then it gives us 50, 60, 65, 82. So that's how you read that there. But now we learned a bit earlier that we want to print the variable in your console. How do we do that? We just put the name down. Boom. So here at the bottom in your console, we are seeing 50, 60, 65, 82. But like I said, it could be numerical values, or we can use characters. So let's say animals. Assignment operator, and I'm going to use a concatenate function. Concatenate is put together, right? It puts it as a 1, basically, right? But very important, when we use characters, it should also always be in inverted commas. Okay, so mouse, we want to say rat, not rate, Angelique. And dog, okay, you see when I wrote dog, it's not green anymore. If I say dog, now it's green. I'm going to run that. And now in our variable, we're seeing it's a character. It has 1 to 3 entries, meaning 3 entries, mouse, rat, and dog. So again, the quotes around mouse, rat are essential. Without the quotes, R will not pick that up as a character. So now we can go and analyze these 2 new variables that we created. We can say length. We want to see the length of it. You can see that's a base function or argument. And we want to have that of the weight in grams. So let's see what it says. It says, okay, there's 4 entries. The length of the vector is 4 entries. Great stuff. So let's say the length of animals. Angelique, sorry, everyone. The length of the animals is 3. There are 3 entries. Super duper. We can now go again and we can see what class they are. And I'm going to show you now what class means. So we're going to class of weight. So the class is, it's numeric. And we see class for animals. And they are all characters. Super, but now we might want to get all this information all in one. So we can use the structure argument, str, and we're going to say wait. So what's it showing us? Numerical, there's 4 entries, and it pushes out the 4 entries. We can say str for animals, and it's going to do the same. Character, there are 3 entries. The entries are mouse, rat, and dog. I quickly need to just answer the door. I'm hearing someone's there. I will be back in 2 minutes. I do apologize, everyone. Take a comfort break. I'll be back.
Did you go to work with it? I'll go too. Please, I go. But no, because I'm scared because of why I'm pummeled. I don't know why. I'm
Apologies, everyone. There's great to work from home. However, when people knocks on the door, you kind of need to shift your day around it. Okay. Welcome, Rafil. We're great to have you on the call. Let's quickly get going. Right. So you can also use the concatenate function to add other elements to your vector. So let's say, right, oopsie daisy, for the weight underscore gram, I was supposed to also add a 30. A 90. So how I'm going to do this? Not easy. I'll show you how. Wait, and we're going to use that assignment operator again. Then we can say concatenate, right? Boom. We're going to say the variable name again. We're going to say comma 90, and we're going to run that. Boom. If you look in your global environment, you're going to say it says 50, 60, 65, 82, and 90. And it's still numerical, but it has now 5 pieces to that. So let's say I also forgot to add 30 to the front of my vector. So 90 was supposed to go to the back, but 30 is supposed to go to the front. So we're going to say wait, assignment operator. We're going to use concatenate again. Now we're going to do it the other way around. 30, and we're going to say wait. And now we can see it has 6 entries, 30, 50, 60, 65, 82, and 90. And we just want to print it to see it properly at the bottom. We're going to do this again. And in your console, which I'm highlighting now, you can see that. Right. Any questions? So right now, okay, I don't see any questions in chat right now. So you can do this over and over if you want to add to this your vector, right? But atomic vector is now the next thing we want to chat about, is the simplest R data type and is a linear vector of a single type, right? So it's either a character or numeric. So above we saw 2 of the 6 main atomic vectors. And we have a bunch of them. So we have character and numeric, I showed them there, and there's 4 others. Logical, I'm gonna copy and paste this into the chat for you guys, right? So you can follow along. So we have logical, which I mentioned, and one day I'll chat it. There we go. So logical, which is true and false, a Boolean type of style data. Integer, which is I don't really use integer data, so I can't really think on the spot of a good example. Who can give me an example of integer data? Here in the example, it says integer numbers like 2L, the L indicates to RR that it is an integer. Who works with integer data and we can give us a good example? Phil, where do you work with integer data?
Yes, I do work with integers.
Do you have an example for us? Sorry, psychology, we don't really use that. Is it
The
double quotes
integers
for characters? Always, yes. Thank you, Eddie. Good
yes.
question. Phil, where?
So the integers are our numbers and they can have commas.
Ah, like 2.2, 2.3 meters. Okay.
Yes,
Thank you.
yes.
Yeah, see, I don't measure things in psychology on that level, so that makes absolute difference, right? Thank you so much. So the next first is logical, then we have integer, then we have complex. And complex is to represent complex numbers with real and imaginary parts, like
Sorry.
y equals mx
Angelique,
plus c. Yeah?
we've got a question in the chat.
Mm-hmm. How can you
It's
extract a single value from a vector? Thank you. Yeah, we're going to do that in a little bit. We're going to do that in a little bit, so I don't want to spoil all the fun. Thanks, Piers. Raw or bit streams that we won't discuss further. I'm going to be honest with you. I think this is very sciencey / hypothetical. Yeah. Thank you so much. A day, month of the year could be an example of integer data. Thanks so much, Amy. Right, so we're going to do a challenge now, and the challenge is in the Etherpad. Let me just see here. So I want us to do exercise 2 and 3 in the chat. I'm going to put them in the Etherpad right now. So let's take 10 minutes for that, and we'll come back and if I can eventually get this copied. Apologies, everyone. Right. Okay, so exercise 2, because we did exercise 1 informally, and exercise 3. So you can put your answers in the chat or in the Etherpad, however you wish to do that. So let's take 10 minutes, and then we'll get back to the answers very soon. Remember to save your scripts. Once you're done, please add done in the chat so that we know we can go on. How are you all doing? We have about another 5 or so minutes left, right? Unfortunately, we're going to have to go on just to make sure we cover everything today, but I also want to give you time to practice this as well. There we go. Thank you so much. I'm seeing answers in the Etherpad. So maybe while you're still busy with that, let's just go ahead. So the first question was, we've seen that atomic vectors can be of type character, numeric, integer, logical. But what happens if we try and mix them? So the right answer, or you can see, they all change to the same atomic vector, right? So it's either they make them all characters or all numerics, etc., etc. So thank you so much. That is exactly what happens there. And then exercise 3, what will happen in each of these examples, right? What happened to a number, the num character? Let me share my screen and we can all do it together. I don't know why I'm not doing that. Hang on a second. There we go. Righto. So let's say num character. We're going to run that first one and see what happened. So num character, even though it's a 1, 2, 3, and an A, I know they said do use class, but we use a cheat, the global or the environment kind of helps us a little bit along, right? So we can see that this whole vector has been changed to a character. So the 1 was put in inverted commas, the 2, the 3, because we know that characters can only be characters if they're in inverted commas, right? So let's see the logical, num logical. Interesting. So when we use Boolean, true and false, it changed it to a numerical. So true is 1 and false is usually zeros, I think. Yeah, let's try that. Let's try my theory. Run that. Yeah, false is 0. So that's our C's false. So let's go change that back to true so I don't confuse anyone. There we go. We run that back. Cool stuff. So a logical, we're going to run that. So char logical, let's just find that. It made it a character. So because we have characters and we add Boolean, it still made true a character. Okay, great. And the last one, tricky. Even though 4 is a 4, which is a numerical, right? But it was in inverted commas, it made the whole vector a character. That's quite interesting. Righto. Let me quickly see where we are. Tell me, why do you think, now think about a research mind, right? If you're analyzing data and you have different types of data, why do we need to put it all in one type? Who wants to take a shot? This is maybe like one of those random questions, but why do you not want to mix these different type of vectors. Anyone wants to take a stab at that? But I think maybe I can just, I put that in there, it wasn't really a question. It is more, oh, Rafilwe, go ahead, please, help us.
Well, the issue comes in when you want to maybe perform statistics analyses in a certain column and you have text in that column as well as numbers, then you're going to get an error.
Yeah, because your program is not going to know what data is numerical, what's character, but you're running a big, let's say, a big latent variable modeling, a big model with different levels and stuff. Totally. All right. Thank you so much. Yeah, I think this is essential why you need to know what structure, that str argument I showed you earlier, what structure the data is in, so that you know what type of analysis you can do, right? Cool bean. So we're going to move on to subsetting vectors, and now that's going to answer your question a bit earlier. So we're going to start with creating a new variable called animals. We already have one, but we're going to replace it. We're going to say assignment operator. We're going to say concatenate again. We're going to say mouse. We're going to say dog, and we are going to say cat. And we are going to create it. So we can see there, it's a character. It has 3 entries, mouse, dog, and cat. Boom. Now I want to pull out the second entry. How do I do that? I'm going to show you now. And we're going to use now square brackets here, and we're going to say 2. So the second position is dog. So we see that at the bottom. Dog was in the second position. We pulled that out. So let's say we don't just want to pull out the second one. We want to have the third and the second one. So we can use a concatenate function for this again. So we're going to say square brackets, concatenate, and we're going to say 3 and 2. So I want in that order. I want the third one and the second one to be printed out. Boom, cat and dog. So I hope that's an introduction to how we pull out data from a vector. So now we can also repeat the indices to create an object with more elements than the original one, like we did a bit earlier. So let's quickly have here. We're going to create a new variable called more underscore animals. We are going to say to use the animals one we already created, square brackets. We're going to concatenate. We're going to say, give me the first entry, the second entry, the third entry, the second entry, the first entry, and the fourth. So I'm making a new vector by using the animals vector, but I'm saying give me position 1, 2, 3, 2, 1, 4. But we kind of have a problem because I didn't add 4 in here. So I'm going to go back, and this is great from R. I'm going to say rat. I'm adding a 4th one in here. So I'm going to highlight it. Boom. So now animals is mouse, dog, cat, rat. Great stuff. Now I can go what I already here coded. I'm going to run that. And now we have more animals. It's 6 characters. Mouse, dog, cat, dog. Well, for now. But now I can't see it anymore. Don't worry. We're going to use class. More animals. It's a character. So now we're going to use structure. I'm sorry, everyone. I'm trying to be too quick here. Boom. So it's a character, 6 entries, mouse, dog, cat, dog, mouse, rat. Okay. So now we're going to continue with conditional subsetting. So I just want to divide this up so I'm not confusing anyone. Conditional. So conditional subsetting is another way to subset by using a logical vector, the true and false statements, right? So true will select the element and false will not. So let's quickly do this. We're going to say we use the weight gram variable. we're going to say assign, we're going to make a new weight gram variable, right? We're going to say concatenate. We're going to say 21, 34, 39, 54, and 55. So we're creating a new variable. Yeah? Let's say, there we go. It's numeric, has 5 entries, etc. But now we want to pull out data out of that vector we just created. So we're going to recall the variable. We're going to, again, use square brackets and the concatenate. We're going to say we want the first one, so it's true. We don't want the second one, so it's false. We don't want the third one, so it's false. We don't want the, we want the fourth one, sorry, so it's true. Woo! True. And we want the fifth one, so it's true. So let's push that through. So the answer is 21, 54, 55. So those are alternative ways of doing that. I'm just reading the chat. Thanks, Yasiel. In the environment, is there a tag or indication of a code line number in the script where that variable was established? No. At this moment, I don't think there is one. But when we take a break a bit later, I'll do a bit of a Google search. Maybe, maybe not. But you can also use the Control F function. And let's say weight underscore gram. That's the first time it came there. So that might be one option of dealing with that. I know it's not what you're exactly looking for, but I think what you are looking at, we are constantly changing the same variable into different numbers, right? So you want to see where maybe the last time or the first time it has been created or changed, right? So that might be the question you're asking. Okay, awesomeness. Thanks, Yasiel, for the question. So next we are going to just play a little bit around with the weight gram variable. And now we're going to say, okay, we want R to tell us which of that vector, all the numericals in the vector, which kind of satisfies a condition. So let's see that weight. We want to see how many of them are greater than 50. We're going to say in that weight vector we created, which ones are greater than 50? So you're going to say the first one wasn't, the second one wasn't, the third one wasn't, the fifth one was, and the sixth one. So let's go to the weight underscore gram again. So 21's not, that makes sense. 34's not, 39's not. Okay, this makes sense. So the fourth and the fifth one were greater than 50. Okie dokes. Let's see. And we can actually now, I don't want the true and false thing. I literally want pull me the numbers. I want to see which numbers are this here. So this is how we do it. Weight underscore gram, curly brackets again. We're going to say weight greater than 50. Boom. 54 and 55. So what we did here is you can combine multiple tests with conditions of true and false and numericals, and you use the one that works best for you. This is typically what you won't analyze your data this way, but these absolutely are essential basics for using R in your data, right? So now let's make it a little bit more complex. We're going to say, okay, pull out the numbers for me. Don't tell me true and false, right? Pull out the numbers for me of weight gram that are greater than 30, but smaller than 50. So let's see what's going on here. So we're going to start again with the variable name, boom, square brackets. We're going to say weight. We said greater than 30, and not or, and they have to be, the weight has to be smaller than 50. So let's see what happens when we do that. Okay, so there is one variable that comes out, 21. 21. So let's double check that. So it has to be greater than 30. So 34. Wrong sign into the 30. Thank you so much. I was kind of wondering, Angelique, what's going on here? So we said greater. No, greater. Let's run that again. Boom. Now there's 2. Yeah, thank you, Yasil. I was like thinking, I did something wrong here. So let's look at it again. So greater than 30, the 34, 39, 54, 55 includes. So that excludes 21, right? But we say smaller than 50. So that excludes 54 and 55. So that's where we get our answer of 34 and 39. Awesomeness. Now we can use an OR function, or in R, we use the sign. It looks like an L, but mine is next to my enter. So I'm going to put it in context for you right now. We're going to say this or this. So wait, square brackets. We're going to say wait again. We're going to say it must be greater and equal . Greater, I'll answer your question now in the chat, sorry. Greater and equal to 30. Or wait underscore equal. I'm going to tell you now why R needs equal. Let me just double check my script here because I got sidetracked a little bit. That's wrong. I said smaller than. That must be smaller than. I do apologize, everyone. So let's see what throws out here. And we can kind of dissect this again. So we're saying it must be smaller and equal to 30, but equal to 50. So that's an OR sign. So anything smaller than 30 and equal is 21. We know this. And equal to 50 will only be 55, or 55, sorry, will only be 55. So that's why we get the answer. So we have a question in the chat. How do we tell the program to select only numbers and leave out words from a vector that is a mixture of words and numbers? So that's interesting. We did in the previous thing, R will not see it as a mixture. R will automatically make it character, or it will automatically make it numbers. Remember the exercise we did previously? That's what happened. So R will automatically do that. But now this is where you need to keep a level head. Remember when we said if something has inverted commas around it, it will pick up as a character, even if it's a numerical. Is that the intent? Do you intend it to be analyzed as a character or analyze a numerical? This is going to, I think, where OpenRefine becomes great, where you clean your data up before the time to make sure that your data is in the form it should be. I hope that makes sense. I do apologize. But that is a great question, right? That is a great question because sometimes we deal, let's say, in a psych questionnaire, we're going to say, okay, and it might be a questionnaire that's a bit complex to code or to analyze. We have a question of how many people do you have living in your household? So some people might be 0, 1, 2, 3, 4, 5, 6, 7, 8. Some people will write none. Some people will write null, N-U-L-L. So that's type of instances I think you're referring to. So when we clean our data before the time, these are things we need to just clear out. Okay. So the next one we're going to try, we're getting a bit more technical every single time here. We're going to say wait underscore square brackets. And now we're going to do the following. Wait. We're going to say greater and equal to 30 as previously. And wait equal to 21. Who wants to tell me, do you think what's going to happen here? Look at the numbers, 21, 34, 39, 55, 54. What might happen here? Who wants to take a shot? We're saying numbers greater or equal to 30. Do we have that? Yes, we do. And go ahead.
Well, I think it's gonna pick all the numbers greater than 30. And then, because there's an and there, and then it also picked 21, if 21 is in the set.
Okay, let's see what happens. Let's see what happens. It says 0. There's no number that is included there because we're saying greater than equal to 30. So it includes only 34, 39, 54, and 55. But the number must also be equal to 21. There's no 21 in there, so it gives us a 0. Right? So now just I want to quickly say that R, we should be careful by using just one equal sign. If we want to say something is truly equal to something like X, the weight underscore gram is 21, right? We use double equal signs. So that's just something that I think you need to just tie in your ear when you work in R. It's going to be a bit of a mind shift, but I'm sure you can do that. So let's go to characters now. We're going to go to animals, and we're going to assign the following animals to this vector. We're going to start with mouse. We're going to start with rat, not rate. Oh, Angelique. Dog. You see it's not going green again because I didn't put the commas in, inverted commas in. Let's say cat. And let's say another cat, because you need 2 cats, right? Then, if we want to return all the rats and cats in that vector, we're going to use the following. We're going to use square brackets again. We're going to call up the variable object again. We're going to say equal cat. We're going to use that OR sign again that I showed you just now. Animals, and we're going to say equal rat. And we're going to run that. So we're saying this or this. So it's not and, right? This or this. So what happens? We're getting rat, cat, and cat. So the first entry, the third entry, and the fourth entry that's coming out. Now, if we want the logical vector to be extracted, we're going to use another new function I'm introducing here. It looks like a percentage mark in and percentage mark. I'm going to show you now. And this, we're going to use a little bit more in visualization on Friday as well. So we're going to say percentage mark in, percentage mark. You see that kind of turned gray. Then you know you're doing it right. Let's quickly see. Sorry, let me just see. Using a single equal sign seems to create a variable. Is there a reason why? Okay. I think the assignment operator is there to say, I'm assigning this value to this vector object. So that's why I use assignment operator. The equal might be used in calculation of something else. 1 + 1 = whatever. I think R is programmed this way so that confusion doesn't happen. So I hope I answered your question. But thanks, I'm loving these questions, everyone. I really appreciate them. So let's go back to how do we extract logical vectors from the animals vector. So we had animals, and we used that, the new function, the percentage in percentage that turned gray. And now we're going to use concatenate again. We're going to say rat. Oh, I don't know what's up with me with rate. Cat. We're going to say dog. We are going to say, oh, no, not the engine. Dog. Then we're going to say duck, because why not a duck? Sounds like some cricket to me here. And goat. And we are going to say bird. We are going to say fish. In inverted commas, obviously. So let's run that. I wonder why it's, do you see what's going on here at the bottom? Let's dissect that quickly. So we're saying, thank you so much, Taj. Much appreciated for your comment. So let's see what we did. We said, okay, tell me in a logical vector term if rat is in the vector. Rat is, right? We know this. Cat is? No. Is rat? Let me just get my ducks in a row here, everyone. Sorry. No pun intended. I just want to make sure I'm not talking absolute nonsense. I'm going to have to come back to this one because for some reason, this just doesn't make sense to me right now. Wondering if I did it wrong. Anyone, I'm going to open the room up here. Taj, refill with someone. For some reason, I'm spacing out at the moment here. There are 6 animals, but only 5 outputs. Thank you very much. Let's have a look there. 7 animals. Thank you. Let's go have a look here. You are right. 1, 2, 3, 4, 5, 6, 7. That's very interesting. Why do you guys think that is? Because we know rat is in the Angelique, you are confusing yourself. Let's have a look in the global environment. Yes, still thank you. You put me on the right track here. So we know, let's go back. I'm going to go structure. Structure, animals. We know now, structure. So the first entry was mouse, rat, dog, cat, cat. So we are checking this list here that I'm highlighting against animals. So mouse was not found in here, correct? So it's false. Yes? Thank you so much, Taj. Rat is in there, so that's true. Dog is in there, so it's true. Cat is in there, so it's true. And cat's in there, so it's true. There we go. Thank you for all your support in the room. It is definitely co-teaching this at its best. Thank you, Taj and Rafaelware. This is how we do it at the Carpentries, everyone. I'm going to finish up with missing data, and then we're going to take a bit of a break, everyone, and then I'm going to hand it over to Rafaelware. So let's say, and we spoke on Monday a lot about missing data, yes? Let's do that. Missing data. So R was designed to analyze data sets, and this includes the concept of missing data because in psychological terms, we have surveys and people can opt to not answer a question, or there might not be a measurement, right? So when doing operations on numbers, most function will turn NA if the data you are working with includes missing values. So if you know your data set has missing value, because you cleaned your data, you'll know if it has or not. You need to tell R there is missing data. Now you're going to tell me, Angelique, okay, that's great, but how do I do this? Let me show you. We're going to go back. We're going to make heights. We're going to make a new variable. Assignment operator. We're going to use concatenate again. 2, 4 in A, because that's how we decided to code missing values. And R recognized that. So I'm going to run that quickly. So we can see it's numerical. 5 entries, 2, 4, 4, NA6. Great. But now let's do a bit of math on this, a bit stats on this. So we're going to say, give me the mean of the vector heights. It says NA. And I told you in a bit, I told you earlier why this is happening. So I'm going to say max of heights. Exactly the same thing is happening. But what I'm going to show you now is how to tell R that there are missing values. We're going to say mean. Again, we're going to say the variable we want that, but we're going to add the following, na.rm true. Because by default, the back end, by not telling R there are missing values, it picks it up that they aren't. So I'm going to run this again. Boom. So that is the average for, or the mean for, right? So we're going to say the maximum. Let's do the maximum as well. Right. So we're going to say na.rm. See, it already picks it up. True. No. True. Boom. Okay, so the maximum value is 6. Great stuff. So if your data includes missing values, you might also want to look at functions like is.na, na.omit, and complete cases. So what I'm going to do is, because this has a great explanation here, I'm going to copy it into my script. So let's quickly have a look at that. So extract those elements which are not missing values. So if I'm saying, okay, so extract out of heights the values that don't have missing values, I'm going to do the following. So it extracted 2, 4, 4, 6. So that's when you use the is.na. But please note the exclamation mark they use there, right? So the exclamation marks mean it's not present. So returns the object with incomplete cases removed. So it does something very similar. Let's see if that's the truth. The returned object is atomic a vector of type numeric for double, right? There we go. And then extract those elements which are complete cases. The returned object is atomic vector of type numeric or double. Let's see what's happening here. Okay, there we go. So it seems like complete cases and is not missing is almost the same thing, right? But honestly, in my experiences, I've only used na.rm in my analyses. So because in my view as a researcher, right? So let me just make that clear, is I will clean the data. I will tell R that I have missing data, and I'll make a new data frame or new subset of data, correct? So I would rather want to work with a data set that's kind of clean and ready to use than to constantly try and remember, exclude the omitting, you know, type of thing. What I would also suggest is you must think carefully, and this is not in this lesson material, it's maybe just me as a researcher. How do you want to deal with missing values? Do you want to totally exclude them? Do you want to, sometimes people clean their data and then they do mean replacement? I'm not saying I opt one or the other. I'm just saying there are options, methodologically speaking, that you can think about when analyzing your data. And do you want to just miss? Because what will happen is sometimes, depending on the package you use, let's say you have 100 people that completed a survey, but 15 of them have missing values. Some analysis will exclude those 15 totally. Are there ways to use the missing data but still keep the 15 there? Do I have to replace the data with means? What do I need to do? So these are things you can think about before analyzing your data. So let me just see, I think there's only like a little summary I want to share with you today. So I'm at the end of my section today, and it is 11 o'clock. I think we're doing okay for time. So the assignment operators used to assign values to the right, on the right to the object to the left. Code should be saved with the source pane. We also shared a resource on how to put automated savings there. I haven't used it myself, so I can't say if it works or not. We can use hashtag to add comments to your code. Functions can automate more complicated sets of commands and require arguments as inputs like square root, etc., etc. Vectors are composed by a series of values and can take many forms. Data structures include vectors, data frames, etc. Vectors can be subset by indexing or through logical vectors, as we spent most of the morning doing. And many functions exist to remove missing data from data structures, but I also want to caution you, as one researcher to another, to find out your options. Also, if you're using categorical data, meaning a survey where you ask someone, please rate your experience from 1 to 5. That's categorical, it's not numerical data. So how you deal with missing data also influences that. So this is now from one researcher to another, and I'm going to keep quiet about that. Rafiwe, I want to hand over to you, but should we take a 10-minute break? Because I think this is well deserved.
Yes, definitely. Let's take a 10-minute break and I will take over after that.
Super duper. Let's all meet 16 minutes past the hour. No, 21 minutes past the hour. That's 11:21 in South African time. Righto.
Yes.
Thank you for sharing this with me, everyone.
Are you still there, Angelique?
Indeed, I am.
Okay, a quick one.
Yes.
Missing data in this case, say if I have a CSV,
Yeah.
because it could either be blank or there's an NA, as in capital NA. So what is missing data in your translation?
I think this is part of the, if I understand your question correctly, apologies. I think this is a part of the data cleaning process. I would not leave the, in the CSV file, right? I won't leave it blank. I would transform the blanks to NA, and then I would import it into R. Because by stock standard, R picks up NA as missing data. I hope this makes
Capital
sense.
NA.
Yeah.
It makes sense. Yeah.
Yeah, capital. Okay, super.
Yes.
Go
Yeah.
make
Yeah,
yourself
sorry,
a cup of
because
coffee. Yeah,
yeah,
sorry,
sure.
go ahead.
Yeah, simply because I've not dealt with missing data before. I think so.
Mm.
It was an oversight on my part. So yeah, thanks. It's very clear. Thanks. Yeah.
I think you should be grateful you haven't dealt with missing data. No, I'm just kidding around. In some disciplines, you will get the occurrence of missing data more than others. In psychological data, or let's say behavioral science data, definitely you're going to get it far more than in other places. If it's observations and you are the one observing and you are measuring things and stuff, probably not. So yeah, I think capital NA, that's your best bet.
Excellent.
Chue, is there any way that
Hello.
we can just maybe make the wording of your script and your console a little bit bigger? There is a way. Let me just quickly, I think it's your global environment or something. It's just, it seems quite small on my end.
It's small.
Yeah,
Yes.
but it's because, you know, everyone has different sizes of things. Let's see quickly, tools, no. Okay, well, R needs to start on my end again, sorry.
Okay, okay. Mm. Global options, maybe?
Yeah, so go down to appearance on your left-hand side, fourth from the top.
There.
Yeah, and then you can put editor font size, all those things. Let's see. You can zoom it
Editor,
in.
can I do zoom or maybe editor
Try
font
it.
size?
You can try whatever. Yeah, that sounds good.
Is that
See, there we go.
better?
Yeah, oh, that's much better. Yeah, that's super.
Awesome.
Okay, sorry for interrupting.
No, that's cool. Thank you for pointing that out. We don't want anybody squinting through the lesson. Hello, everybody. So we are going to move on to section called Starting with Data in R. Yesterday we were supposed to, I did say that today we will finish off the last section of Open Refine. If everybody is okay with it, can we please do it after this section of starting with R? Can I please have a thumbs up? And then after that, it will just be a quick 10, 15 minutes to do the last part of Open Refine. Thumbs up. Or unmute yourself. Okay, I got a thumbs up. Okay. Thank you very much. So we are going to continue with starting with data. Oh, right. So the objectives of today are to, or for this section, it's to load external data from a .csv file into a data frame, to install and load packages, to describe. Hello. Okay. Describe what a data frame is, summarize the contents of a data frame, use indexing, describe what a factor is, convert between strings and factors, reorder and rename factors, and then format dates. So the first thing that we are going to do is we are going to load the survey data that we are going to use today. Are we all following on the lesson site? If not, I can just copy the this code line to the chat. Please let me know.
Idea.
Okay, let me just do that so that everybody just gets that going now. Awesome. So what we're doing here is we are downloading a .csv file from a URL. Hence we have URL equals to, and then with the line dest file, we are telling R where to actually put our file. And it's going to be under data_raw, and it will be called portal data joined. So after you run that, please indicate with a done in the chat or a thumbs up. So after you've run this line, you will check under your file called data raw, because you have told R where to put your data, and you will find your .csv file in there. Please type in the chat done or indicate with a thumbs up if you are done with that part. Okay, so the data set, as I mentioned, is stored as a, my URL is showing as green. Let me check. My big screen has so produces as error when I run. So you're still getting an error. What does your error say?
I feel okay. So the error says, okay, it's quite a long one. Let me just post it to the chat.
Okay, that's fine. Check that I copied it properly. Is anybody else getting an error? Download had non-zero exit status. Okay. So let's go back. So it says you cannot open the destination file data underscore raw, and that's probably because you don't have a folder called data raw. So let's just backtrack. Yesterday or earlier today, when we were dealing with starting with R, we made a folder called data raw. Everybody who does not have that folder, please indicate in the chat, unmute yourself, just let me know, and then we can just quickly make that.
Yeah, also important that that data must be a small d.
Yes, and it's a small d.
Yeah, it's very case sensitive.
Does everybody else have that folder? Yes, Theo, I'm just gonna.
So I do have it. I had it from yesterday as well in my file section. So I can see it here. Underneath my file section at data underscore raw as a folder, right? So
Yes.
is that all I need, or
That's
there...
all you need. You need that folder. So when you run this line, it will send it to that folder
Okay.
and give it this new name.
All right.
Please try again.
Yeah, let me try and figure out what's going on here.
Just have a question. You mentioned it was green.
Yeah.
Yes, he said it's green. Is it possible that
You have a hashtag in front of it or something? Because the only thing.
maybe
No, it's green after it's green when it's when you reach the URL. So it's only after the equal sign after the URL in the script. So
and
everything
it
else
looks
before that is
exactly like
black.
this?
Yeah, I copied it straight from your message.
Let him share the screen so that you can correct.
Okay.
Okay.
Please
Good
share
idea.
the screen.
Sure, we'll do. Okay. Let me just make it a little bit bigger. Okay, so that's what I'm looking at.
It is green. Mine is blue. Is it possible?
Yeah, I just think it still does
it's
look
just
right to me.
yeah. I think it's probably nothing really. It all looks the same.
Hmm.
And when you run it again, still nothing.
Hmm.
Same error here. Peter also gets the same error. Download file, data raw, big share. I am not understanding. Because I just ran it again.
Hello? For him
Yes,
not to
Tajudeen?
waste the time, yesterday we downloaded it into the data folder. Let him go to the data folder. You will see the file there. Let him go and copy it and place it in the raw under data underscore. Data
Oh, okay.
underscore. We downloaded everything yesterday.
Okay, okay. Please check in your folder called data if you have that same data set, portal underscore data underscore joined. Because Tajudeen did actually, yes, I remember he actually did do that.
Okay.
Please move it to, so Peter says he's downloaded into downloads. Please just move it to data underscore raw.
Okay.
If you cannot find
Right.
it, I will look for my own and place it in the chat.
Okay,
Okay.
perfect. Thank you. Okay. Thanks so much. I'll stop sharing.
Awesome. Okay, thank you. Is my screen visible?
Yep.
Awesome. Okay, so we are either moving files to data underscore raw, or you've used this line of code. apologies, and everything ran. And now you have a data set called portal_data_joined.csv in a folder called data_raw. Right. So in this, the data that we have read into
Let's
the
it there,
data
let him download it there.
pardon?
In the chat, let him copy it and put it there.
Taj, I didn't hear what you're saying properly. Oh, there's in the chat. There it is.
Mhm.
Yes, so please download it from there, put it in the folder called data_raw. Should I give you guys a minute? Please indicate with a thumbs up or unmute yourself when you're done, just so that I don't lose you. Then we can move on. So 11:33, we move on. Great, so I see a thumbs up, so assuming everybody is okay. So what we have done is that we have just downloaded the data into the destination that you specified with using dist file. But what has happened is that R has not yet loaded the data from the file into memory. And for that to happen, or for you to see that that has happened, you would see it in your environment. That would mean that R has loaded into memory. So for us to load the file or the data into memory, we use read_CSV. So before we run read_CSV, well, actually, it's fine. We can run that. Can we just run that first? And some of us might get an error. So please tell me if you are getting an error. So I'm going to copy the code there. So that's the code. We run surveys, we assign that, and we run read_CSV. Is anybody getting an error after running that? Thumbs up, unmute yourself. Anything, indicate. Or a hands up. Okay.
Sorry, I'm
Yes.
looking for that string there you just, in 169. That's what I'm looking for.
169. I put it in the chat. You can copy it from the chat. Did everybody find it? So chances are you will get an error. So I won't get an error because I already have the package that's needed. The reason why you're getting an error is because read_CSV is a function from a package called tidyverse. So if you don't have tidyverse installed on your R, on your environment, then you will not be able to run that. Oh, okay. You already loaded tidyverse. Oh, wonderful. So let's go there. So then let's run surveys. Okay, sorry. Must first run library tidyverse. So I haven't run tidyverse this morning. So
It is read
yes.
.csv. Read.csv.
No. we're going to use the tidyverse one, read underscore CSV. So the mistake I made was I did not call library tidyverse. So before you use the package, even though it's loaded, even though it's installed, you need to load it using library tidyverse. There we go. So then the next thing what we're going to do is we are going to assign a name. We are going to assign a name. Did my surveys wrong? There we go. We're going to assign a name to the .csv file that we have, and we are going to call it surveys. So please let me know when everybody is at that point. Please let me know when you're at that point with a thumbs up or unmute yourself. So after we assign that name to the data that we have downloaded, what you are going to see in your console is this output. So it starts by telling us how many rows we have in our data, how many columns we have. It tells us that the delimiter is a comma, and that is expected because we are using a CSV, right? And then it's telling us that we have 6 columns that are character and 7 that are double, right? So as we see, read underscore CSV assumes that the fields are delimited by comma because it is a comma separated file that we are actually calling. However, some people or some other researchers or maybe from different countries, they use a comma as a decimal separator and a semicolon. And if that is the case with you, the file that you're downloading, you can use read underscore CSV2 function. And from that, you will be able to change you can also change the delimiter into how you actually want R to read your file. Right, so we want to now see what do we have in our file, right? We have downloaded it, we have put in the memory of R, but then what? So what if we want to just have a snippet of what is exactly or what kind of data we have in the file, we can run head surveys, right? Is everybody there? Maybe I should make this smaller. Right. Everybody have a clearer view? Please indicate with a thumbs up, unmute yourselves. So by running head surveys, we can just have a preview of what we have in our data, right? And so we can see that the first six rows, this is what we have in our data. Yes, Peter?
I seem to be struggling to do that line of surveys with the CSV, with that data raw and total gen CSV. So
you're still running there?
Yeah, it gives me an error. Another one when I try to do the data with the code.
So do you have, so Tajuddin just shared the data in the chat. Did you download that data?
Yes, I downloaded it and I took it under the folder of data underscore row.
And it's under data underscore row. So when you run this exact line, you are still getting an error.
Yeah, I just
it says portal. Let me just check. Angelique and Tajuddin, can you see the error properly?
Yeah, it says I can't read it because there's no data in the directory. I think there's a directory issue here. Peter, can you share your screen with us?
Yeah, I have a feeling maybe he's not in the project.
Yeah, that's kind of what I'm thinking too.
Yeah.
How do I go for share screen?
So if you
At
go
the
to your
bottom of your
bottom,
screen, you'll see a little green, but if you hover over all the mute start video, you'll see a little green icon that says share screen.
are you winning, Peter?
Yeah, I am.
There we go. Right, so let's see. Will you click on in the quadrant? Yeah, over there, raw data. Click for me on that folder at the bottom. There we
Data.
go.
I don't see.
Data is there.
Oh,
There
there.
it is. There it is. Okay.
The data is there. Okay.
Yeah.
Let him share the working directory.
Okay, but I'm not seeing tidyverse being loaded.
Okay, let me see. I did do it before.
Yeah, so it's the, well, no, let's say library.
Let's do library,
Okay.
yes.
Yeah, library. Okay.
No.
I think it's TIDY.
Also remember to close the bracket of the.
There we
I
go.
don't think it's there.
Okay, load that. Okay, it seems loaded, but you need to, that server is line 130. That something's missing there, .csv, something, close bracket, something. So we just need to fix that. Hang on a sec. What is the?
Close bracket, yeah.
Yeah, hang on. I'm going to copy and paste it from Rafael's message so you can get the right one. So it must be joined.csv.
Joined.
At the end, right, of that word. So it says data, yeah, there we go, .csv.
Data was all.csv, ne?
Yeah, but so try and run that again. Yeah, I'm like a little bit confused here now because
I think it has something to do with the directory where it's working from. It's not been saved as a directory where the file is, yes.
There we go.
Is it possible maybe to go to set as that thing which looks like a cog, the blue?
Okay.
Which one?
That's blue wheel to the bottom right. The icon in the bottom right. There are four icons. There are four windows.
Try to set your directory now.
Because I got this model, so now here is the line data capital shop analyzing R, data carpentry file, and data raw. If I go back like here, so this is where my directory ends here, and then so I go in here, and then
Click for me on that data carpentry under the project, right? The second one. Click on that for me. No, one down, one up.
This one.
One up.
This one.
Yeah, click on that. Okay. You are in the right thing, I think. It's okay, you can exit that. I was just trying to see now.
Mm,
What is going on in data and the folder data is it empty?
yes.
Okay, I want you to do something there. That CSV folder, move it to data. And when that in line 130,
This one.
yeah, move that one to data and the data folder there. And then when you're done with that, there 130, where it says data underscore raw, take that underscore raw out. I want to just see what's going on there. I'm moving the data to another folder. There might be a conflict or something. I don't know. I'm literally grasping straws here.
Okay.
Sorry, Raphael, I'm taking over.
No, that's cool. That's cool. That's why we are here, so we can help.
And then after moving, I change the name of this data row. I remove it.
No, just leave it there. That's fine. As long as you move the data set to the data folder, that's fine.
I did. All right.
And then
Okay,
on
and
line
then-
130, change it to data.
Yeah. So yeah, there where it says data underscore raw, ne?
Yes.
Just take the underscore raw away. So because the file directly, we move the data now to another folder. We're just changing the folder.
The destination folder 127. So then we have 136. We have destination folder. To take.
Hello.
Hello?
Hello. When you look at the working directory that is set, if we can just add the data under, the new folder, which is data underscore carpentry underscore how. Let him add it, set your deck. Just copy the working directory you have there, then include under it after the R, the last R, put data underscore carpentry underscore how there to set the data. So you go back to the script folder there, set WD. No, go back to the script data, the environment. Under the get the working directory. Under get working directory. Hello. Just type, go back up, or you can do it on the console. Type it there. Oh yeah.
Then you
start
it.
typing. Set working directory. Set working directory. I taught you yesterday.
Okay,
set
so
working directory. Set working directory. WD. Open a bracket.
yes,
Open a bracket.
they're open now.
You have not opened it. Okay. Then go to the console you have there. The console. Go and copy that link. Copy it. Copy everything. Copy it. Go and paste it there. But you need to put it in quotes. You know that.
Yeah, like this.
Paste it. Put it in quotes. In quotes.
Or in code.
Yeah. From the E, put a quote there. Then that R before the quote, put a forward slash.
Before the code.
No, the R after the R there, the last R, forward slash. Then the folder, which is data underscore carpentry underscore R. If you don't know it, you can put your tab. You press your tab key. Press your tab key to read it. Okay, that's it. All right, close it. Close it now. Close the quote. close the code. Then you can run it. Press your Control Enter key. Control Enter key. Okay, it has set it. Okay, go back to the survey now and run it. You will run now. Control Enter key. Okay.
Thank you. Sorry about this, guys, but thanks. I think it's loaded now. Yeah, it is here.
It's loaded. Awesome. No, don't be sorry about it.
Genius.
Thank you,
Okay.
Tajuddin.
Thank you. Thank you.
We all learn from these errors. I have definitely learned something. So,
How do I stop sharing now?
let me just, it will probably stop your sharing. Right. Is everything okay that side? Can we see?
You see my
Screen.
screen?
Awesome.
Go to
Okay.
view and stop sharing them.
Yeah, I stopped my sharing.
Have you stopped sharing? Okay, there we go.
Sure.
Awesome stuff. So now we are all at checking or seeing a snippet of our data called surveys. So what we use for that, we use head surveys. So when we ran head surveys, we got 6 rows of all the 13 columns. And if you want to maybe see more than that, you can tell R that you want to see the first 50, right? So you tell it surveys. Okay. Angelique, I clicked something here, and now every time I insert my cursor, it deletes the stuff before. But anyway, there we go. So we get 50 rows, and you can see it says with 40 more rows of that, right? So with that, you can also what can I say, extract or what is it? Yeah, you can actually extract the first 50 rows and give that a new name. Give that a new name. So you can call it survey sample. Is everybody following? Do you want me to keep copying the line of codes into the chat, or are you okay with that?
Please, if they can code with you, but just I think someone said they can't access the Etherpad, so that might be easier just to keep copying it into the chat.
Okay. So let's say we want to have a new data set called survey sample, and you just want the first 100 of the rows of this data set. You can do that. Right. So then you have survey sample, which has 100 observations and 13 variables. I just want to copy that in the chat for you quickly. Okay, there we go. So you can code along with me, and when you get errors, please let me know. I'll probably get the same errors that you're getting. Right. So what, Angelique, just to confirm, did you run the function print earlier?
Yes, I did, but you can revisit that. It's fine.
Okay, no. So I just wanted to say, unlike the function print, head returns the extracted data. It doesn't just plonk it on the on the console. You can actually use that to extract data and make a new data set, data frame, right? So if you want to just view your data, you can use view surveys. You can use view surveys. And with view surveys, your entire data frame is open. You can scroll down. And this is a new thing. I don't know if Angelique and Tajideen had seen it before. You can now filter data. Before, we couldn't do that with a click. You would have to code it, but yeah.
Sorry, that is new. That would have made my life so much easier.
I know. So now we can filter with a click instead of coding it. But yes, there we go. So there are two different view functions that you can use. So the view with the small v is actually a function from tidyverse, right? And then I have next here one with a capital V. That one is actually part of base R, and it comes with the utils package, the utilities package that is part of base R, right? So everybody has been able to view their data set, their surveys. So if you run view with a small letter, view with a big letter, with a caps, it gives you the same output. You still get to view your surveys data set, right? Right, so now, you've been hearing me talking about data frames. What are data frames? So when we loaded the data into R, it got stored as an object, which is of a class tibble, right? A tibble is a special kind of a data frame that is part of tidyverse. If you want to know more about it, there is a link in your notes. I will copy it and paste it in the chat if you want to learn more about tibbles. But we are not going to get into tibbles today. You just need to know that a tibble is a special kind of data frame, right? So when we load data into R, the default structure for most of these tabular data that we use is a data frame, right? And then that is what R will recognize, and it will change it to a data frame, right? So you can also make a data frame from scratch. You can code a data frame, but most of the time we just load the data with using the function that we used, read_CSV from tidyverse, and we just generate that from the Excel file or the CSV file that we have, right? So as mentioned earlier, each column is a vector, and it can contain a single type of data, which can be a character, integer, or a factor, right? So if you want to know what type of data you have in your data frame, you use, as we've done earlier, str to check the structure of your data frame, right? So we have a challenge here after running str surveys. Just gonna copy that in the chat. So can you please just run str surveys and then answer the chat, the challenge, which says, based on the output of str surveys, can you answer the following questions? What is the class of the object surveys, right? And how many rows and how many columns are in this object? Please type your answer in the chat, or you can unmute yourself. Yes. So we ran str, and the question is, what is the class of the object surveys? Any answers? Unmute yourselves, anybody? I'll give you 1 more minute. And if you're getting an error with running str, please let us know. Okay, nobody's getting an error, so I should be getting answers. So this is the output that you get, right? Right. So as you can see, when I ran mine, I got class. Okay, we have one answer. So okay, I'll answer the first one. We got class data frame. There. We got class data frame. And then the columns, we have 13 columns. There we have that. And we have 34,786 rows. Did everybody get the same number of columns and rows and get a data frame as the class? Awesome. Okay. So we're going to continue with inspecting data frames. We have already run the function head and structure, and the head was giving us an just a snippet of what we have. Thank you for your answers in the chat. Snippet of what you have of your data, and structure was giving us information on what class we have, how many columns, how many rows that we have in our data frame. Right. So you can also use functions such as dim surveys. I'm just going to plonk it there. Right. So this gives you the dimensions, right? It gives you the number of columns as the second element, and the number of columns as the second element, and the number of rows as the first element. So you got all that from using str, but you can actually do it individually. You can also check the number of rows by using in rows. Right, and yes. Somebody saying something? Or you can check the number of columns using incol. You can do that individually, right? Instead of using structure, right? So we used head to see the first few rows of our data frame. Can someone tell me what we would use to check the last few ones? Unmute yourself, write it in the chat.
Footer.
Pardon?
If I'm borrowing from Word, would it be foot or footer?
Not exactly, but yes, Peter, we have tail. We can use tail surveys. And the same as using head. Yes, yes, Angelique. Think about tossing a coin. Definitely, definitely. Heads and tails. So we can run tail surveys, and also with running tail surveys, we can tell it how many of the last rows we want to see. There you go. So I put 50, so it will show me 10, and then let me know that there are 40 more, right? So another thing that you can do is you can check the names of the columns, right? You can check the names of the columns using names surveys. There. So you can see all the names of the columns in your data frame, right? You can also do row names. There. So row names will give you literally all the row numbers. So we have, how many rows do we have again? I forgot. Yes, that number of rows. So it has literally printed all the number of rows that we have, right? So the next thing that we are going to do is indexing and subsetting, right? So our survey data, as we have seen, it has 2 dimensions, which is rows and columns. And we can extract specific data from it, right? We just need to tell R exactly what we are extracting from it, right? Remember, rows come first. You saw that when we ran dimensions. When we ran dimensions, rows come first, columns come second, right? So when you are extracting specific data from your data frame, you need to remember that you have to follow a certain syntax, right? Which is row index and then column index, right? So just gonna put that there. So we first put the row and the column. We use square brackets for extraction, right? Unlike when we are calling things out, we are using round brackets. That's the syntax for R. Quick question. We have a break due in a minute. Would you like me to continue finishing indexing and subsetting, or take a break now and just come back a minute earlier? Thumbs up, unmute yourself. Angelique, advise. Tajudeen.
Anna?
To you.
We go on a break now and come back a minute earlier.
Okay.
12:19. Okay. Okay, I have a carry on. Anybody else? I just have one answer, so I'm going to go with that answer to carry on. Awesome. I love this. Okay, so what we are going to do now is we are going to extract the first row and the first column from our data frame called surveys, right? And plonk it there. Right. So we see that when we do that, we get 1 returned. We called for the first column and the first row. So if play around with your data and tell me what other interesting things are you calling for. Right. So if we call the first row and the 6th column, we get species ID, there, record ID 1. So are you guys playing around with it? What are you guys getting? You can just put random things there and then maybe share it in the chat what you're getting. So what we can also do is we can select a number of rows or columns at once, or you can select all the columns in that row by, ooh, okay, that's interesting. Let's copy that. and 3. Right. So with that, we said rows first, columns second. So we called row 1 to 4. And then we called column 6 to 8. Interesting. You're advanced. Okay. So that is a way to select multiple rows or columns at once, right? So I was still on, not you, sorry. So I was still on selecting one row, but all columns. So to do that, we leave the columns empty to say that we are extracting all of the columns. So we have row 1 and all the columns. So we have 13 columns and 1 row, right? We can also do that vice versa when we select all the rows, but only 1 column, right? So we selected the first column and then we selected all the rows, right? As you can see, there are many other rows that have not been shown, right? So we had this example, which shows that you can select multiple rows or columns at the same time, right? So we use the colon to show that we are going from 1 row all the way through to the 4th row. So the first row all the way to the 4th row, and then column from the 6th all the way to the 8th, right? So any questions before I move on? Okay, so what we can do also, we can exclude a certain row or a certain column using the negative sign, right? So let me plonk that there. We can exclude. So what we did there is we called surveys all the rows, but we excluded the first column, right? We excluded the first column. So if you want to exclude a different column, that is what you will use. So let's run this one. Wait, I'm going to copy it, put it in the chat, put it on the screen, and then I want you guys to answer me what you think that is going to do. I haven't run it yet. Oh, sorry, I haven't sent it either. There. So what do you think that is going to do? Unmute yourself, answer in the chat. I mean, you can run it and see what it did, and then give us an answer. Okay, I have 2 answers. The first answer says you will just give the first 6 rows. And then the other one says exclude the first 7 rows. Right, let's run that and see. There. So it excluded, so you minus 7 in rows. Right, let's see. So Natasha says exclude the first 7 rows. Is that true, Natasha? Wait, we removed record ID, so I can't even compare. So there's record ID. Record ID, because that's the first column. Peter says include first 6 rows. There we go. We have 6 rows, and we have all the columns, right? Did everybody get that? And does everybody understand how we got that? Yes. Thank you. Okay.
What's the
So-
final, sorry?
Mm-hmm.
Yeah, what's the summary answer?
What's this? There? So we have only 6 rows and all the columns. So we are subtracting 7 to all the rest rows in surveys, and we're including all the columns.
Great.
Awesome. Thank you. So data frames can also be subset by calling indices, right? Like we did there, but also we can do that by calling their column names directly. So that's where when we ran names, when we ran names when we ran the names of the columns, so if you know the names of the columns, you can call, you can subset your data frame using the name of the specific column, right? So you can do it this way. So we called species ID, right? We called the column species ID, all the rows in species ID, or we can call there, or we can call it that way, which still gives you all the rows and only the column species ID, right? We can, let's see, we can also use double brackets to return a vector in this manner. In this manner. There. So in species ID, it has returned all the vectors in the column species ID, right? Survey species ID, can you use the minus sign? Let's try it. This thing is going to give me a problem because of how this one is set up. Okay, let's try it and see. So negative species underscore ID, close that, and there we go. So that's what you want us to run. Yan surveys. Sorry. Surveys. Square bracket.
Sorry, if you were, the minus will be outside the apostrophes, right?
Okay. There we go. Is this the line you want us to run? Take that.
Well,
away.
I'm not sure if that's how it can work.
Okay. You have invalid argument to the unary operator. I don't know why it's getting invalid argument. Tajuddin or Angelique, do you have an idea?
Hello?
Do you have an idea why we cannot use?
Yes, you are having an invalid argument because if you look at the column name, it is not hyphen, it is not the hyphen species ID.
Yes, yes.
So it's supposed to be outside the bracket, not inside.
We did put it outside.
So you did not run the outside.
I
Okay,
didn't
I've
run.
seen the okay, I've
There.
seen the outside.
Yes,
I've seen
there.
the outside one. It's not working. So let me see why it's not working. Can you put it in brackets? Yeah? Put in brackets the 9 before it. Okay.
So surveys, square bracket.
Yeah. No,
yes.
Yes, comma.
Comma.
Yes, a dash.
Mm-hmm.
Then a bracket.
A square
Then
bracket.
you put it, yes, as a the square bracket. Not the square bracket there. The normal bracket. Okay.
Okay.
All right, then the species name. Put it in quotes.
Or put it in quotes. Okay. I don't know what I did to this thing that it does this, but I shall fix it. Yes.
Close the bracket.
And then close the round bracket and then close the square bracket.
The square bracket. Try to run that one. If it's not working, then something.
So that means we cannot do that. We can only exclude it if you're using the index.
Okay.
Right. Does that answer your question? Person who asked the question, who was it?
Yeah, sure. Thanks.
Cool. Okay. Awesome stuff. So the next thing that we're going to do is we can also use the $ operator, unless there's another word for it, another name for it. I call it the $ operator. With the columns instead of double brackets to return a vector. So we can do that and we can get the same. Yes.
So before you go, the double bracket in line 218, you should understand it that it is putting it in a list form.
Yes, it's doing the same thing as that.
It's
as
putting
line
everything
220
in a list form. If you
yes.
check the variable now, it will be in terms of lists.
Okay, so but in this case pardon
it is now in list form, not like a role. It is now in a list form. Maybe you understand what I'm trying to. We have the table, we have the list, we have the dictionary. So this is now in list form.
Yes. So now when you if we assign a name to it and we check the class, then it will be in list. So right now we just pulled it out and we did not assign it. So we will do the assignment and showing the lists later. Okay. Tajudi?
Yeah.
Yes. So I'm saying that we'll show the list one later. So right now we were just showing that you can call a vector. Right. So now we have a challenge that we are going to do. So this challenge says, create a data frame, surveys 200, containing only the data in row 200 of the surveys data set, right? And then notice how nrow gave you the number of rows in the data frame. Use that to pull out just the last row in the data frame. Compare that with what you see as the last row using tail. And I'm just going to go quickly there. Use nrow to extract the row that is in the middle of the data frame. Store the content of this row in the object named surveys middle, and then combine nrow with that notation above to reproduce the behavior of n surveys, keeping just the first through 6 rows of the surveys dataset. So we have basically done all the examples to be able to do this challenge. So let's go on a 10-minute break. During that break, we are doing, no, let's go on a 10-minute break and then give you 5 minutes to do the challenge. And then after that, we go over the challenge and we stop our session for today. Everybody okay with that?
Do you
Thumbs
still
up.
want to continue the open refine bit, Rafael?
Oh, yes, yes. And then I'll just need, after that, I'll just need 10 minutes, 15 minutes to wrap up open refine. We basically just saving the file. Yeah. So 12:37 is your break. And then 5 minutes, use that for your challenge. And then we come back and go through the challenge. I guess, are we almost ready to check the answers for the challenge? For those that have completed number 1 to number 4, can you please give us what you did? Okay, in the chat. So we have surveys 200, obviously the first index. So we are extracting using the index function by using the square brackets. So rows first and then columns after. So we are trying to get only for row 200. So we put 200 a comma and we are saying all the columns, right? For number 2. Yes, that is correct. Yes, that is one observation of 13. So what we did is we assigned the name surveys 200 to what we extracted. That is one observation of 13 columns. And then the next one, we are saving. So what is it asking us to do? Pull out the last row using nRow and then create a new data frame object. Is that what it's called? Yes. Anybody have an answer for that? I mean, I have it on the screen. If you have anything different and you thought there was a different way of doing it, please just let me know. Maybe there is a different way of doing it. Okay, so this is what I have. So we saved nRows, nRow of surveys. And then we have surveys lost. And then we have surveys lost because it says create a new data frame object called surveys lost from that last row that we called. So we have surveys lost. And then the third question says use nRow to extract the row that is in the middle of the data frame and store the content of this row in an object named surveys middle. Right? Does anybody have a different way of doing it from what I am doing, or maybe do not understand how we are getting these answers? So the last one says combine nRow with this notation above to reproduce the behavior of head surveys, keeping just the 1st through 6th rows of the survey's dataset. So to get that, this is what I did, right? So we can call surveys head. There. Or we can use view. Sorry, I'm a lazy coder. So this is the final product. So that is the same as if you used surveys head. Right. Everybody understood? Are we okay? So we're going to end our starting with data in R here for today. And then tomorrow we are going to continue from factors. So I'm just going to stop sharing my R IGE. Just save my script. I'm just going to stop sharing that, and then I'm just going to show you something very quickly in OpenRefine, and I'm sure most of you have already done it, have already seen it, already done it. And if you have, great. So you don't have to follow for this. I don't expect you to go open your OpenRefine again. It is okay. So I just wanted to show you just how we save the file. I mean, we've gone through all this to clean your data in OpenRefine. There we go. We've gone through all this to clean your data in OpenRefine. And after we do that, yes, OpenRefine does save your changes. And as we said earlier, it does not overwrite on your original script. Original data set. So what we can do is we can export our data as a TSV or a CSV. So I'll just choose CSV. And you can give it a new name. I'll keep mine as Portal Rodents New. As you can see, it's a .csv file. Mine is saving it to downloads. You can definitely change where you want to save it. And there we go. It is saved. So that was just me ending off our OpenRefine, how you actually save your OpenRefine data set after cleaning it in OpenRefine. Awesome. So that is the end of the session from me. Please do not forget to use the stickies to give us feedback. And if you have any questions, please put it in the chat or just put it in the Etherpad. The link for the Jamboard where the stickies are is in the chat. Thank you, Angelique. After giving us feedback, thank you very much. We shall see you tomorrow. But before you go, Angelique, Tajuddin, would you like to add something?
Nothing from my end. I'll see you tomorrow morning.
Awesome. Tajuddin, would you like to add something?
Oh, well, there's nothing I can add for now. Let them just go through whatever they have been taught today so that they don't have an issue tomorrow.
Awesome. So
Okay.
go practice what we did today. We'll see you guys tomorrow. Please don't forget to give feedback. Thank you. Bye.
Thank you all. Bye-bye.